All right, so let's introduce how to build graphical user interfaces using Java Swing. So this will give us a chance to what the technology looks like at some of the classes that we want to implement, and it also we'll use a bad design as a use case, right? As a study case. It'll be trivial. It'll work. Right, it'll do what it's supposed to do, but it will point out what's wrong with the design and identify some opportunities to improve it in the next couple iterations. Yeah, so this source code that we're going to be looking at is available from the lecture. If you go to MVC code and you download it. It'll have lots of different directories in there with different source material that you can either have separate, import them to separate projects in your IntelliJ. What I've done is I've added them all under each. I've created packages for each one of them, right? The first example we're going to look at is this one, the bad design but functional, right? So oftentimes the slides or the lectures will refer to a particular directory, right? And under that directory, there's a source code for that particular example. Okay. Yeah. So this first example is as we say, it's poorly written. We'll have a model. We'll have a view. The view will have direct access to the model. That's a no-no. Usually, we want to have a controller in between. But perhaps it's too trivial to be, to really be aware that that's what we should be doing. We will have a really trivial model. The model will consist of a single string, right? Very simple, right? I can set the string and I can retrieve the string. That's all I can do, right? Again, we'll deliberately make it trivial. And we'll make it, a little more interesting as we go. For instance, I'd like to be able to change the color of that string. Maybe I want to capitalize it, lowercase and whatnot. So I can change a couple of things and mutate the model as I go, right? We'll create an interface that captures the different operations that we can do on our model. And yeah, we'll make it deliberately trivial. At first, okay, and then we'll add some new features as we go. So here's the interface for our model. These are the only two things that we could possibly do to a string. We can set the string and then we can retrieve the string, right? So presumably it's a mutable model that it can change over time. So it has its own state. A trivial way to implement this would be to have your own string copy and then you have a setter and a getter for that string. So here's an implementation, a trivial implementation, right, where you have a private string. Perhaps it could have been final, right? At the constructor, we just initialize it to an empty string. And then you have a setters and getters that just update the string or retrieve the string, right? So it's trivial. Right? This is our simple model. Once we have the model, it will. Let's talk about implementing the actual user interface, so that we can capture some of the things that the interface might want to do. We'll capture those kinds of operations in an interface, the IView. It will be our own interface, and whatever other view that we might build later on, right? They would all implement that interface. Yes. How they actually implement it. Right, each one would represent, just like I would have one representation, one view might like to draw things with rounded corners and highlights and different color scheme and a particular font. So that would be a particular view, and you might have a different view, right, that likes to draw things, with square corners and likes to use bar charts, whereas other ones might use pie charts. So different views might implement or render the same exact data. Implement the same exact interface, but render differently. One of them perhaps can render on HTML on a browser, whereas another ones can render on a phone. Yes, but they would all be implemented in the same exact interface. Make sense? Right? Yeah. So the view will have three methods. that will be able to manipulate the data, right? You'll be able to reset the string, clear the current text, be able to read from the input field so it can give you what the user has actually typed at the input field, or just echo it, right, and update a local label, right, to see that you can see what is it that you clicked, that you typed, right? Now it will implement it in a class called JFrameView. So we'll have JFrameView implement IView. The reason for JFrame is that in Swing, the way we pop up a window, right, that we can then draw on, those are called JFrames, right? That's Swing's jargon for a window that I can populate user interface with. Okay, so it'll be our own JFrame that we can then populate with all sorts of controls in there. So here's our interface. It's a trivial interface. We have the set echo, get input string, clear input string, and then we'll have our own JFrame view implement. We'll implement that class. Here's our main class. I guess I skipped over the JFrame view. Where's my JFrame view? Oh, it's coming up. So what the main the main class will do is that it will instantiate the model, right? Presumably that model is implementing IModel. It will instantiate our window, right? And that window, you will get a reference to it in the view. Notice what we're doing here. We're passing the model to the view, right? That's already a no-no, right? We're giving the model directly to the view, and the view presumably will have direct. We'll be able to manipulate the model directly from the view. That's a no-no. Nevertheless, we'll come back to this and fix this in our next iteration. So our JFrame view is where we're going to implement our input fields and whatnot. And actually, might help to just show you how trivial this is. Let's run it. Here it is. If we run this, yeah, there it is. Here's our label, right? When we echo the text that we type, it will update this label. Here's where the user inputs that label. Hello world. And then I can either click on echo, right? It reads my input field and updates that label, or I can exit, right? Also, it's just to point out, if you resize this window, the way this behaves is that it overflows. If it doesn't fit in a single screen, in a single row, it wraps, right? That's another concept in Java Swing, is that the way the actual input fields or the buttons and whatnot are laid out on the screen, they're following a strategy that you can configure. This is called the flow strategy, right? Or the flow layout. It lays out the input fields using a strategy that you can configure. This one's using the default strategy called the flow layout, right? Meaning they flow from left to right, from top to bottom, right? Because we are a Western-centered culture. We read from left to right, from top to bottom. Perhaps in a different culture, it would have been laid out from left to right. So that's the default layout, and everything wraps. Anyway, so it's a very simple way to just throw something on the screen and forget about it. There's a whole bunch of layouts. You can lay it out with a header at the top, a footer at the bottom, like a left-hand side, a right-hand side, maybe a centered content. It's called a border layout. You can lay it out as grids. There's a whole bunch of layouts that you can use. Right here, we're using the most trivial one, just a flow layout, and then we can just exit. All right, excellent. So let's go on. Right. So our entry point, right? Obviously, it's our main. But our main is instantiating this JFrame view. Really, that's where the interesting things happen, right? So JFrames, as I mentioned earlier, JFrame is Swing's representation of a window, right? That we can then either draw with a canvas, right? Or we can add a whole bunch of user interface controls to it. And basically, the steps are trivial. you instantiate a whole bunch of controls, input fields, buttons, labels, whatnot, right? And you add to the frame, right? You add to the frame, and then you can configure these controllers to then, you can configure event handlers, right? That if you click on the button, you want to invoke this function. If you type at the input field, you want to invoke this function, whatnot. So you can configure all that inside of a JFrame. You can have the JFrame be the listener to all these events and be able to handle all these incoming events, yes? And that's what we're going to do. We're going to handle everything in one single class. Right? Later on, we'll come back to this and we'll try to break it out. Right? But to keep it simple, we're going to have everything in this one single class called the JFrame view, which is going to extend JFrame. Right? So my JFrame view will be a JFrame, and then it will pop up in a window with all these controls. Right? When you say set visible, then it just pops up and displays. Okay? So what we're going to do here, we're going to add 4 components: a label, an input field, and 2 buttons. Right? And I just show you how they work. Right? You type at the input field, and the 2 buttons are handled and update the model. Right? And then the model is used to then display the label. Yes, and then you exit. We are using the flow layout, which is allows you to lay it out simply from left to right, top to bottom. There's many other types of layout that we're going to take a look at a little later, but this is the simplest one that will get us through today, right? And we suggest to just resize to see the behavior. Yeah, so there's quite a few other layout managers. At the end, usually the way this works is that you add to the frame, add any number of elements, and once you're done, you call pack on the frame. It says, hey, pack, meaning recalculate all your positions. Having told you all these elements, right, that I want to be rendered, go ahead and calculate where everything goes, right? Depending on their default sizes, depending on the text of the label in the buttons, depending on the text in the labels and whatnot, recalculate, right, and put everybody where they go. Calculate the actual positions of these controls. So here's our JFrame view. Right, this is where everything interesting happens. Notice that it's extending JFrame, right? Meaning I am a JFrame, and when I extend JFrame, I get I inherit all sorts of behaviors, right? Like being able to resize myself, set a particular size, set a particular background color, fonts. I have all sorts of behaviors that I inherit. I also noticed that we're implementing the IView, right? And remember, the IView was able to, echo, was able to retrieve the string, set the string, right? All those methods that I'm going to implement. I'm also an action listener, meaning I am going to listen and I'm going to handle all the events of those buttons that you click, or any keystrokes that you generate. Right? I'm going to be a listener. I can handle these events. Later on, we're going to break that out. I'm going to say, no. We're not going to have the view handle all these events. Instead, we're going to break it out into a controller. The controller will deal with this, right? One example when I first was trying to understand model view controller that really drove the idea home to me is that when you're before MVC, you might have multiple pages or multiple screens or multiple elements that you want to navigate from, and so you would have each one of these screens or web pages, whatnot, that would handle their own navigation, where you would have perhaps a hyperlink that would allow you to navigate from A to B here, or maybe another hyperlink that allow you to navigate to C over here. And maybe another hyperlink that allow you to navigate to D. So the actual logic of knowing where I should go or what I should do if some user event that came through, right, was in that screen. The screen handled all that action. Yes, and that would be true for any screen, right? This one would go like that. And this one would go perhaps that way, and perhaps this one would go back. Right, so this is the same thing that would happen if you would have a go-to, right? That from anywhere you could decide to just jump anywhere you would want, right? You would end up with this spaghetti code, right? That you would have no way of, it's very easy to create something very tangled, right? That you would not, it would be very, very hard to follow, what happens, what, when, okay? And so one of the things that MVC introduced was the fact that, no, we're not going to do that. The responsibility of deciding what should happen when should not be spread out over 6, 12, 24 different screens. It would just be maddening. The maintenance of this would be unwieldy. Instead, ideally, all that logic of deciding what should happen when, depending on user input, right? Instead, it would be much easier. Instead, if each of these screens, they would not have that responsibility, right? Instead, they would delegate to a centralized place. They would centralize place and says, you know what? This event just happened. Somebody just clicked this, but it's not my responsibility to know what should happen. Instead, I'll put that in a single place, right? A centralized controller. And this controller can have maybe a configurable file, maybe in XML or in JSON or some configuration, maybe with a nice little GUI, right? With a nice little GUI that would allow us to drag and drop what should happen, yes? Right? And now the maintenance becomes trivial because there's a single place of maintenance as opposed to spread out over multiple artifacts that I need to maintain individually. Make sense? Right? If I have this spaghetti code and I had this hard-coded navigation and I wanted to introduce something in between that before I go to D, I should first go to D prime. Right? I would have to go everywhere, right? That was going to D. I need to update all of them, as opposed to having one single place and I can just update in one place. Yes, right. So we were able to identify, right, what are these concerns of the view will only render, right, but it will be dumb, right? It won't know what should happen when the user clicks on checkout or add to shopping cart. It is not its responsibility to deal with that. Instead, we're going to rip it out, right, and maintain it separately. Yes, right. So yeah, so controllers allow us to to circumvent the bad old go-tos, right? Of just creating this this tanglement, right? Anyway, so here we have the view. Again, its responsibility: instantiate the elements, the components, the display, the two buttons that we're going to need, the text field, and unfortunately the model. Right? We're going to keep track of the model here for this first attempt, this naive attempt. We instantiate that. We have the in the constructor. We can initialize ourselves, right? We can say how big we want the screen. We can locate ourselves on the window on the screen of the main screen. What should happen when we click on the close? By default, nothing happens, but we can configure that the system should close, exit. Also in the constructor, we can instantiate all the elements. We can display instantiate a JLabel, instantiate a text field for folks to type in. We can type, we can ask how big do we want the text field, how many characters big. We can instantiate two buttons and pass in the label of the buttons, so it would be echo and exit. Once we have those, we can set the layout. We can say, hey, frame, I want you to lay out the content using the following layout manager, whether it's flow layout or grid layout or a border layout. There's a whole bunch of layouts. We can say use this layout, and then just add them. Add the exit button, the display, the input, the echo, and the very last thing we say pack, meaning go ahead. Make it so. Just recalculate all these positions based on what I just gave you, right? And now display yourself. Just render yourself on the screen. Once we do that, we can also configure all these buttons. What do we want to happen when we click on these buttons, right? And what we want to happen when we type. There's a whole bunch of event handlers that we can configure. At first, we're going to have this JFrame view be the event handler. So the same JFrame view be the one who handles all these clicks and typing and whatnot. Later on, we'll rip it out and have the controller be the one who handles these. But for now, everything will be in the same one place, right? We'll need to provide some callbacks and say, hey, when this button is clicked, then you should notify this one place. Okay. Also, in particular, right now we're only going to focus on the two buttons, right? We're gonna ignore the fact that folks are typing at the keyboard and they're typing at the input field. Later on, we'll come back to that. All right. As a feature, we're going to add being able to also listen as a type. But for now, we'll just focus on two buttons, right? And the one is I think one of them is echo, right? Meaning read the input field, update the model, right? And then render it in the label. And then the other one is exit, right? Just clicking on the exit and the whole thing dies. As a convenience, Swing allows us to associate a generic string or a string to each button, right? A unique string to each button, which is referred to as the action command, right? You can put any string that you want, so that whenever the button is clicked, that string comes back to you. And you can easily use it maybe in a switch statement and say, okay, well the action command was this, echo or exit or clear or whatever, right? Whatever action command string comes back. And then you can drive your logic that way. Maybe perhaps a finite state machine, right? That implements your logic, right? Yeah. So let's do that. We'll create an action listener. Notice that our JFrame view implements the action listener. Yes. That's an interface. Implements that interface. So being that interface, you have to implement one function, one method. Okay. And that method is the one who's going to be notified. Whoever implements that method is the one who's going to be notified of what button got clicked, right, or what keystroke got generated. So let's do that. Right now, we'll come back to this a little later. But for now, we're just going to have one single listener, right? Only our JFrame view will be notified. Okay. Although Java Swing allows you to declare any number of listeners, right? Where if you click a button, you could say that you can have many listeners listening for that event, right? And Java Swing can broadcast and say, well, whoever's listening out there, somebody click this button, right? Handle it, do something about it. We're gonna consider just a reduced version of that, where right now we're just gonna have one listener. Okay, again to simplify things, but we'll come back a little later. Also, because we are implementing the action listener interface, this is the method that we need to implement. The action performed method is the one who's going to be notified. This is going to be our callback, who's going to handle all these events. Okay. So here it is. This is still in the constructor. Still in the constructor, we're going to tell every button that we're going to associate these unique strings with each one of our buttons, so that when somebody clicks on it, we can use that same string to determine, which button did you click? Oh, it's the one with this string. Yes, right. So we can label it echo button. Also, we're telling it when you click the button, this is who you should call. Who? This frame, this JFrame view, because it's implementing the action listener interface, right? And it has a method that implements there, which is action performed. Right? Action performed is declared in that interface, right? So here it is. Here's the action performed. This is the method that is declared on the action listener, right? And what it gets us as an argument is a generic action event. Right? That action event could be either a click, it could be a keyboard stroke, it could be a mouse movement. All of them would go through here. This generic action event. And from here, you could retrieve the string, the original string that you associated with it, with the action event. For instance, echo button or exit button, the various buttons, and then do certain things. What we're doing here for the echo button, right, is we're going to get input string. Now, get input string, if you remember, was one of the methods in the IView interface, right? I think there was get input string, set input string, echo, right? Those three methods, right? So those are specific to the model. We're going to get the input string. We're going to update the model. So the get input string gets it from the input field, right? Gets it from the input field. We're going to update the model. That's a no-no, right? The view has direct access to the model. We'll come back to this in a minute. And it's updating the string with saying, model, update yourself. Here's a text. We're going to clear the input string, so the input field gets cleared. Later on, we're going to retrieve from the model, and then we're going to echo. We're going to update a label, right? So just a really, really trivial interaction between the view and the model, setting it, updating it, and then retrieving, read, write, and update on the model. And then we break, and then I think we have right after that, another case, another switch. The exit button just does a system.exit 0. Okay. We still have, so these are the three methods that were declared on the IView interface. Right. All views should implement this interface, right? Whether it's HTML, whether it's a phone, or whether it's a desktop JView, whatever that we have here, they should all implement this interface. They can either set echo. That's going to update the label on the left-hand side, right? As we type and we click on echo, or retrieve the input string from the input field, from the text input field, or reset it and clear it. Empty it out so that it's ready for use for the next use. Yeah. So these are the three that are declared on the IView. Right. We'll come back to this a little later. Admittedly, hard coding this logic here in the event handler is also a no-no. Right. We've seen better implementations using the command pattern, right, from when we were doing the turtle, right? That would be a much better solution where we could grab all this logic of what each event handling should happen, encode it either in a class, right, with a .execute or a go or run, yes, right, that would actually update the model and whatnot, or in Lambdas, right, in Lambdas with a anonymous function that would allow you to encode all that and delegate the execution of all this logic to later on when you run it. Right? So a better solution we'll see a little later is to use lambdas or anonymous functions, anonymous objects. This is just temporarily, right? This is a temporary convenience that we are embedding all this in the view. Okay, we'll come back to this as a better solution in a bit.